Hey guys, so today we are going to talk about the combined gas law, which helps us explain what happens to gases as pressure, temperature, and volume changes in respect to moles of a substance. Okay, and basically the combined gas law is Boyle's law, Charles's law, and Avogadro's law combined all into one equation. Okay, so of course, just a little quick review of your variables, P's for pressure, and we do have atmospheres, millimeters of mercury. We also have torr, which is the same as millimeters of mercury. They're both the same value. We have kPa as well as psi. Okay, volume, we have liters, milliliters, cubic centimeters, and cubic meters. Okay, and don't forget that 1,000 milliliters is equal to 1 liter, and then 1 milliliter is equal to 1 cubic centimeter. Okay, N is number of moles. Remember, we get the number of moles from our balanced equation. And a lot of the times we are going to just give you moles. A lot of the times moles is not going to be your unknown. Okay, and temperature, remember that temperature is always measured in Kelvin, and to find Kelvin, all you have to do is simply add 273 to your degrees Celsius. The subscript of 1 is going to be your initial variable, and then subscript of 2 is your final variable. Okay, and then if N is not given in your problem, we are going to assume N to be 1 mole. Okay, and most of the time this only applies to the combined gas law. Okay, so again, temperature must be in Kelvin. And then remember STP, standard temperature and pressure, is going to be 1 atmosphere. And then temperature is going to be 273 Kelvin or 0 degrees Celsius. Okay, so if we take a look at our first example, okay, a hot air balloon has the volume of 750 liters at 270 Kelvin and a pressure of 1.2 atmospheres. What will be the volume of the balloon if the pressure changed to 0.90 atmosphere and the temperature decreases to 230 Kelvin? Okay, so the easiest way to do this is to go ahead and identify which givens are which variables. Okay, so if you go through the paragraph, this is going to be our initial volume. This is going to be our initial temperature and our initial pressure. Okay, and then it tells us that the volume of the balloon, what will be the volume of the balloon if these variables change. So pressure changes to 0.90 atmosphere, so that's going to be our P2. Okay, and then temperature is going to be 230 Kelvin. Okay, and then don't forget that N was not given, so we can assume N to be 1 mole. Okay, now if we plug in all our givens into our combined gas law equation, you should see something like this. Okay, and then of course, how do we solve for our unknown when we're given fractions? You would simply cross multiply. Okay, so when you cross multiply, you should get all these numbers, all these variables. And then, of course, basic math, multiply all of them, multiply, and then these are the large numbers you get. So still, again, how do you find your unknown? Well, we would divide by 243, okay, and we would see when we have them divided that this is where our units are going to cancel each other out. And the only unit that we have left is liters, which should match what we're looking for. Okay, so our answer would be 8,518.5 liters. And of course, when we take a look into the number of significant figures our problem gives us, the least number of significant figures it gives us is 2. So it would round to 8,500 liters for our final volume. Okay, so if you want to go ahead and try to do guided practice number 2 on your own, please do. Okay, but if not, let's go ahead and keep going. Okay, so the volume of a gas at STP is 22.4 liters. At 12 degrees Celsius, the volume of the balloon changes to 55 liters. So what is your new pressure? Okay, so again, let's go ahead and take a look at what our givens and our unknowns is. So our initial pressure, this is going to be 1 atmosphere. Now, where did I get that? Remember, STP is technically 2 variables. Okay, so standard temperature and pressure. Well, standard pressure is 1 atmosphere, and that's where we're getting our value for that. Okay, V1 is going to be 22.4, it was given. Okay, N1, remember, it was not given in our problem, but we're going to assume it to be 1 mole. Okay, because we don't know what gases we're working with, so we wouldn't be able to write a chemical formula for it. Okay, T1, okay, is going to be 273 Kelvin. Again, STP, standard temperature is 273, so that would be our initial temperature. Okay, P2 is our unknown. V2 is going to be 55 liters. N2, again, it was not given, but we assume it to be 1 mole. And then our final temperature was 12 degrees, but of course we do not use degrees Celsius, so plus 273 to 12, and we get a temperature of 285 Kelvin. Okay, so we plug in all our givens and our unknowns into our equation, and we should get something that looks like this. And then, of course, to solve for our unknown, since we have fractions, all we would do is just simply cross multiply. So again, you would get all these units and numbers, multiply this all, and then multiply this side as well. And these are the values that you get. And we still have an unknown. So then we would divide by 15,015. And when you divide those two values, this is where your units are going to cancel out. Liters cancels out liters, moles and Kelvin cancel out each other. The only unit we have left is atmospheres, which is our unit for pressure. So divide those two numbers and we get 0.42517 atmospheres. And if we take a look at the number of significant figures, our final answer should be 0.43 atm. And that's our final pressure. Okay, and I believe that is it for combined gas laws. If you guys have any questions, please feel free to leave a comment or ask me in class.